Welcome to Briavel Institute. It is a multiple decrement model. So it is coming under the CM1 actuarial mathematics, and we have 240 plus classes available. So visit the www.briavelinstitute.com, and there is a registration option. Login and register the website, and then you can learn. You can subscription option is there. Different types of subscription option is available. So whoever is interested, you can visit the www.briavelinstitute.com. So here is a multiple decrement model. So we last three classes we studied the multiple state model. Multiple state model. What we studied the multiple state model. So here it is a healthy state. Here is a healthy state. So H is representing healthy state, and here it is a sick state. Sick state is representing S, and dead state. Dead state is representing D. So now you see in the multiple state model there is a transition from it. Here we represented sigma x, this is a rho x, and this one we represented the nu x, and this one we represented as mu x. So this is the transitions. So this is a multiple state model. So in this multiple state model, what is things is happening? Healthy state, from healthy state to sick state, sick state to dead state, and healthy sick state to healthy state. Again, there is a transition from healthy to sick, sick to healthy, and transition healthy to dead. Here only dead state we can call as a absorbing state. Dead state we can call as a absorbing state. Why it is calling a absorbing state? Because once is reached here, there is no outgo. Here there is no outgo. There is no to going to any other state, because it is end. It is a end. This state is a end, not because of dead. It is a state is ending. There is no outgo. There is no transition from the dead state. So that is why this dead state is calling as a absorbing state. So in multiple state model, this is a multiple state model, we have only one absorbing state. Only one absorbing state. Now in multiple decrement model, we have a one or more absorbing state. So what is the option? We will delete some of the transition is going to delete. Then it is becoming as a multiple decrement model. Now you see, this is a multiple decrement model. In this model, what is a absorbing state? Here is a sick also absorbing state. Sick also absorbing state. Why it is absorbing state? After sick, there is no transition from the sick. There is no transition. Whoever is reached in the sick state, it is absorbed. It is completed. There is no transition from the sick state. So some health insurance policies, sick insurance or health insurance policy, they will pay once you reach in the sick state. They will pay some lump sum. For example, 75,000. When you reach in the sick state, you will get the 75,000, and policy closed. Policy is over, because there is no return back to healthy state. So these types of model we can call as a multiple decrement model. You see, in this model, you see, healthy to sickness, it is an absorbing state. There is no transition from the sick state. Healthy to death, it is an absorbing state. There is no transition from the absorbing state. For example, here you see, if you are dead, you get the lump sum of $100,000. So this types of decrement. Decrement is happen from here to here or here to here. There is no transition from there. So these types of model is called the multiple decrement model. In multiple decrement model, we have some more expressions are there. For example, we are healthy to sick. How we will represent in P, S to T, H to S. So we are representing healthy to sick. So people are X, age X, he is in, at the age of X, he is in healthy state. At the S plus T age, he will reach in sick state. So this is a representation. P, X, at the age of X, he is in. So this one we can write as a probability of at the state, at the age of X. State S at the time, age at the age S plus T, given that. So at the age of S plus T, he is in sick state, given that at the A state H, at the age X. So this is a probability. So this probability we already studied in the last 2-3 classes. At the age of X, he is in healthy state. At the age of S plus T, he is in sick state. So instead of this representation, we are going to represent one more representation at the age of AQ. AQ at the age of, this is a dependent probability. This is a dependent probability. We are writing that. We can't write given that like that. It is a dependent probability. It is saying that at the age of X, at the age of X, he is an active state. Dependent probability is saying that at the age of X, he is an active state. That is AQ. AQ means it is, there is a transition is there. At the age of X, he is in active state, and at the and is removed from this state, removed from this state, and you reached to sick state, the sick state, at the age S plus T. So what is happened here? Transition probability is another one more representation is representing here. At the age of X, he is in healthy state. At the age of X, he is in healthy stage, but at the age of S plus T, he left from the healthy state. He left from the healthy state due to S. So here, this decrement is representing sickness. This one is representing sickness. If a decrement is not due to recrement, this decrement is due to retirement. Retirement means we will represent a R. As in, we can write here. What is the meaning? At the age of X, he was in active state, and he is in leaved from the active state. He left from the active state due to R, retirement, due to R at the age of S plus T. And another more representation, decrement due to death. So at the age of X, he was in active state. At the age of X, he was in active state, and he left from the active state due to, what is it? Due to death. So he will represent a D, due to death. He death state, due to death, he is left from this active state. Due to death, he left from the active state. So that is the meaning. What he left from he removed from the active state due to death. What is this probability? This probability is a probability of S plus T time he is in sick state, and state H time he is in active state. He is in active state, and probability that he is in sick state, that is in S plus T time. Here what is there saying? Whoever is there at the time of X, at the age of X, his active state or healthy state is removed due to death or due to sick. Sick means you will put a S. Due to sick, how many people are removed from the active state at the time of, during the period or during the time of S to S plus T. So that is a difference here. In this case, we can write like that. Within a year of time, P of S H S is within a year of time, 1 year. Within a 1 year, S to S plus 1. So S to S plus 1, we can consider the S to S plus 1 year only. S to S plus 1. Within a year of time, what is happened? Is active state, it is going to 1 year, we can represent instead of T, we are representing 1. So 1 year not representing here. S to S. It is equal. What is the meaning here? Whoever is an active state, healthy state at the time of X, and within a 1 year, S to S plus 1 year is in sick state. S plus 1 year, that time he is in sick state. We are using where active state at the time of X and is removed from this state, active state, due to sick at the during the period of S to S plus 1. So this both are equal because there is no return back. We can consider return back also, then we will understand what is the difference. And here one more things we can write like that same is a 1 P of H, H to D. So what is the meaning? He is in X time. X time is a very active, is a healthy state. But S plus 1 is a S plus 1 time. Instead of here put a 1. H plus 1 time, what happened? He is in death state. So this is equal. Whoever is left from the healthy state. Whoever is left from the healthy state due to death. Due to decrement is a death. That is a decrement is showing here. This is due to decrement. That decrement is representing here. due to decrement. So this also we can write as within a 1 year, S2 S plus 1 is in active state, but he is due to death. That is a decrement. Decrement due to death, he is moved to the death state. You moved to the death state. You're not saying that like that. What is the probability of left? Dependent probability of left from the active state due to death. That only is representing AQX. What is the dependent probability of left from the healthy state or active state due to death in during the period of S to S plus 1? That is this representation. What is this representation? Probability only, but at the time he is active, but S plus 1 time he is in death. Both have some differences there that we can take in a next drawing. We can study like that. And one more thing, if instead of this is a AQ is a, there is a transition is happened. Instead of that, we have a APH. APH. So what is APH? What is the meaning APH? During the period of year, APH will represent here APH. During the period of year, 1 year of time, here is representing S to S plus. During the period of year, people are not moved to sick, people are not moved to dead. He is in active state. Active state at the age of H and at the age of S plus 1 also is in active state. We can write like that, H to H. This is equal. In this case, it is equal because there is no return back to healthy state. So now you see, S is equal to 1 P of H is HH. During the period of S to S plus 1, he is in active state. Still S plus 1 also healthy state only. Healthy state and healthy state. Here is representing healthy state in H and S plus 1 time also healthy state. Hope you understood about this representation. There is a two more. Here is a transition is happened. So we are representing as a active state. From the active state, transition is happened due to decrement S. Here also see transition is happened. So representing as a Q due to decrement. What is a decrement? It is a D. Here there is no transition is happened. So we are active state. We use the P. There is no transition is happened. We are in an active state only. Now we can check with the so here we can make some more formula here. Healthy state. This APH. This is what are the probability here? What are the probabilities there? Now you see APH. What is the meaning of APH? Whoever is here probability that he is an X. X age X is in age X, he is staying in healthy state, continuously staying in healthy state within during the year of S to S plus 1 year. S to 1 year is continuously staying here. And here AQ X S, what is the meaning? Probability that whoever is staying in the active state is left from the active state due to sick, plus AQ SD. What is the meaning? Whoever is staying in the active state due to at the age of H due to death he left from the active state. So this three probability equal to 1. So there is a people are staying. Here is a, for example, here 1,000 people are staying in the healthy. 1,000 people are staying in the healthy. So probability of 1,000 people are staying in the healthy. Here 100 people are moved to the sick. 25 people are moved to the death. So this whole probability. So here how many people are remaining? Remaining is 875 people are remaining in the healthy state. So this three probability, people are moved from the healthy state to here and moved to the death and who are staying here. This three probability if you are taking, it will be a 1. And APH also we can write like that. APH is equal to 1 minus AQH S minus AQ SD. We can take this both to that side. Like that also we can write. And one more representation. AQH. AQH, what is the meaning? It is in a probability that he left from here. He is in X, age X, he is in active state, but he left. That AQH will be a, he, what is two options? AQ X S plus AQ HD. So what is the meaning of AQH? Here is not showed any what is a decrement. Some people are left here. How many people are left? Here 175 people are left from the healthy state. 175 people are left from the healthy state. once not 75, 125 people are left from the healthy state. Now you see 125 people here. What is the reason? 125 by 1000, here is 125 people are uh, left from the active state. This is equal to what is here, it is a s is 100 people, 100 people are left, and plus here it is a 25 people are ahead, so this will be equal. How many people are left? This is due to sick and only two options left from the active state, S and D. So this is the representation, this is the equation, probability, this is also probability, so we can write like that also. Hope you understood about this probability. This probability means whoever is staying here plus whoever is left, total probability will be 1. Whoever is staying here, here is the 875, 875 divided by 1000, here is the 100 divided by 1000, here 25 divided by 1000, this total probability will be 1. And here is the this one, this 2 probability you can take it to that side, then like that also we can write. Hope we understood about the AQS representation. Now we can we can learn about what is the difference between this HS and HD. If this drawing, this here, it is both are equal. Why it is both are equal? There is no transition. This is an absorbing state, this also absorbing state. There is no transition. So in this multiple decrement model, these are equal. Now we can change. Here we are going to change. One small change is putting sick to death. Sick to death. Sick to death we are put as a new H. So this model you see. In this model, sick is not absorbing state because it is out is there. Output is there. From sick state, people are going to the death state. So there is an output. Sick state is one temporary state. On sick state, there is people are going to death state. So there is this absorbing, this sick state, we can't say it is a absorbing state. So it is a dead is a absorbed. Here only one state, dead only is a absorbing state. Then what will happen? This whole details will change. This two details will change. We can check with the whether it is equal or not. We can write it is a 1 P of H S, whether is equal or not to AQ H S, whether it is equal or not, we can check. Now you see H to S, H to S, people are moved from H to S, so we can say that 100 people are moved from H to S. 100 people are moved from H to S. So what is the probability? Here we can write the probability. 100 people are moved from H to S, 100 divided by 1000. AQHS, 100 people are left from the healthy state. But in HS, what is the meaning? He is in at the age of H, he is in healthy state, healthy. But at age of S plus 1, he is in sick state. So number of people are moved to 100 people are moved from healthy to sick, but 10 people are moved to the dead state. Though how many people are here in death state? Death state only 90 people are available. 90 divided by 1000. Here is what is the difference? Here whoever left, here is left, that is the AQS. Whoever is left from the healthy state to sick state, that is represented here. Here is not representing like that. At the time of H, he is healthy state. At the time of S plus 1, he is sick state. At the time of H, he is healthy and 100 people are moved to sick state. But at the time of S plus 1, what happened? Some people are died. Some people are died. From sick to dead. Some people are died. Some 10 people are died here. So what happened is a 90 by 100. So it is not equal. Which is higher? This is higher. AQHS is higher compared with the HS. AQHS is representing whoever left from the healthy state. So it is 100 people are left from the healthy state. 100 people are left to sick state. Left from the healthy state and reached due to sick. Here what is happened? 100 people are left, but out of that 10 people are died. 10 people are died. So finally we checking, it is only 90 people are available in sick state. At the time of S plus 1, only 90 people. Here in this case, we are not considering whoever is gone for the death. We are considering only how many people are left. That's all. So this is the that equality. This will be higher. And we can check this is also 1P H HD. HD and AQ HD. So this one you see, which will be higher or equal, whether it is a equal or higher. You see, whether it is a equal or higher. What is the meaning? We can put the same example. So 25 member is died directly healthy to death. So what will be left from the healthy directly to dead in 1 year? So it will be a 25 divided by 1000. So this probability will be a 25 divided by 1000. But in 1 p of x hd, what will be the probability? Whoever in healthy state, x in the healthy state, here you see, x will be in the healthy state. At the time of age x, he is in healthy state. At the time of x plus 1, he is in death state. How he died, that we are not considering. How he died? Now you see, here, directly 25 members are there. 25. Directly 25 members are died at x plus 1. This is the absorbing state. Plus, here sick state, 10 member also reached in the death state. So this 10 also we have to add. Sick state 100 members are reached. Out of 100, 10 members when reached to the death state. So this is total 1000. So what is a higher? This one is a higher. This probability will be higher. Why? Because it is reached to sick state and dead state. So s plus 1 time we are searching how many people are dead. Now is a different route also, no issue. So how many people are died? He's a 1000 people are active healthy state, but 25 people directly died, 10 people from the sick also died. So this both will add in the case of hd. So what is happened? 35 by 1000. So it will, the probability will be here is a higher, here is a higher. And what about this value? That will also we can consider apx and apx, whether it is equal to p of x h to h, whether it is equal or not. You see, how many people are left from the, in this case, 100 people are left like that, 25 people are left like that. How many people are left? So out how many people are staying in the healthy state? It is a 875 divided by 1000. Here is a h to h also 875 divided by. In this case, it is equal, because there is nothing. Once is left, is not returning back to healthy state. Healthy state to sick state, it is going to here. Healthy state to dead state, it is going to there, and not returning back to healthy state. So we can say that is both are equal. Both parameters are equal. Hope you understood about the multiple decrement model. And we have considered one more model. We have to understand what is the, whether it's a AQS, whether it is equal or not. For understanding the equal or not, we considered one more model. In this model, what happened? This is higher, probability is lesser, and here is the probability is higher, because of we consider the death, and here is only left. So these three things we considered. Now we can do one problem solving. Hope you understood about what is a AQX and APX. Now we can do one problem solving. So in multiple decrement model, we have, here is only death and retirement. We can write here. Here in a pension scheme. So in at the age of 60, healthy person is retired, and at the age of 60, at the age of 60, and here is a retirement option is there, and death option is there. So we have a age 60, and AQXR retirement. Due to retirement, what is a transition rate is 0.1. So probability is 0.1, and AQX death is probability is 0.03. Death probability from the age at 60 to 61. 60 to 61, during the period of time, what is the probability of retirement? 0.1% of people are retired. And what is the probability of death? 0.03%. 0.03 is a probability. Here at the age of 61, it is a 0.02, it is retired, and 0.04 is a death is happened. Now we are going to find out. Is age 60. First question is saying that the probability of retiring during the year of age 61 to 62. During the year, first probability has to find out, or probability of retiring during the year 61 to 62. During the year, what is the probability of retirement during the year 61 to 62? So during the year 61 to 62, year 61 to 62, what is the probability of retirement is 0.2. But here what is the difference? Here some people are retired 60, so here is a people are retiring only during the period of 61 to 62, during the age of 61 to 62. So we have to consider all people are alive at the 60 to 61. So here 61 to 62 only alone we are asking 61 to 62. So what is happening? 60 to 61, what is happening? Not retirement, he is alive. 61 to 61 people, and 60 to 61, what are the probabilities are there? Retirement is there, death is there. And here we are asking only 61 to 62, what is the probability? So is alone is asking 61 to 62. So probability of retirement at the age of 61 to 62. So what is happening? 60 to 61 is active state. 61 to 62, there is no not dead or retirement, nothing is happened. And 61, AP 61, what happened? 61 he is retired. So 61 he is retired. That is a probability. AP 60 means 60 to 61 is active, 61 to 62 he retired. So this both cases has to consider. Then only we'll understand alone age is 61 to 62, how many people are retired. So AP 60 means 60 to 61 is active, and from that 61 62 he retired. So AP 60 is not given here. How to find out AP 60? So in this case AP 60 we can find out AP 60 plus AP HCR plus AQ HCR AQ HD is a 1, total 1. So we can AP 60 we can find out 1 minus 0.1 minus 0.03, so it's 0.87. 0.87. So this is equal to 0.87 multiply with the this probability is a 0.2. So it will get a 0.174. So 174. So in this question, so question is given in the right side. You can read the question. So what is happened here? It's a probability of retiring during the period of 61 to 62. We want to find out a 61 to 62. So what is happening 61 to 62? Only the particular period. So what is the probability of only the particular period? What is the probability? 0.2. But here what is happening? 60 to 61, he should be an active state. How many people are active state in the 60 to 61? From that, what happened? Retired. So it is a 0.87 is active state is 60, and it is a 0.174. And one more problem we can ask here. Probability of dying an active member before age 62. Before age 62. Probability of dying before age 62. Probability of dying, death is happened before age 62. Age 62, before age 62. So AP 60, whoever is died, we have to consider, plus AP 61, whoever is died, both has to consider. Before age 62, before reaching age 62, he died. So we need to consider what we need to consider. So AP, it is AP 60 due to death. 2 years of time, how many people are died? We have to find out the 2 AP, AQ, not AP, AQ 60 died. So it's a transition is happened, we will represent a Q only. So AQ 60-year-old person, at 62 number of people are died. So this is directly we can't find out this formula, because we have a first AQ at the age of 60, how many people are died. So this one is a 60 to 61, how many people are died. So that is AQ 60 to D. 60 to D. 61 to 60 to 61, how many people are died? Plus, we have some plus is there. And 61 to 60, so people are alive at the age of 60. People are alive some people are alive during this year 60 to 61, and from that what happened? AQ 61. AQ 61. So this is the probability of dying before age 62. So at the age of 60 to 61, this much. This is directly getting from here. AQHD, this is directly getting 0.03, 0.03 plus. And in that 60 to 61 people are alive. From there, what happened? People are died. So AP60, we find out AP60 is 0.87. 87 is AQ61. What is AQ61? It is 0.04. 0.04. Totally will get 0.6, 0.0648. 0.0648. Hope you understood about this problem. Is before age 62, how many people are died? So that is what is the probability for dying? So age 60 probability directly died age 60 to 61. Here it is in people are died in. Here it is. We are during the 61 to 62. In this time, how many people are died? So 60. Some people are not died. From there, we have to find out the probability of 61 to 62. How many people are died? And one more problem we can discuss. Same question. One more problem. Probability of still being an active member at age 62. What is the probability? Probability of being an active member. Active member means healthy state. This is also called as active. Active member at the age of 62. At the age of 62 is an active member. So what is the meaning? 2 AP 60. In the 2 years of time, he is staying in the same active state, not retired, not died. So that is a probability we have to multiply with the AP 60. He is in active state, multiply with the AP is in active state AP 61. So this one will get 0.87. And AP 61, how will you get? AP 61, we can write side AP 61 is equal to 1 minus 0.2. 0.2 minus 0.04. It will be 0.76 will get. So multiply with 0.76, you'll get 0.6612. 0.6612 will get. So this is a probability. Now we have studied the multiple decrement model. In this decrement model, we have a different types of decrement model. This is a retirement, decrement due to retirement. How many people are left? Retirement due to retirement. How many people are left from healthy state due to dead? So that is why we have represented as a AQ. We studied AQ XR. How many people are left from the active state due to decrement retirement? And here is the AQ X due to death. Or AQ we studied X. Yes, this is due to sickness. How many people are left from the? So this three we studied, and one more thing we studied APX are still in active state, not moved from this. So this three particular important notification we studied how to represent here. Hope you understood about this multiple decrement model. So thank you.